All right, day 2 of lesson 10.4, we're going to move on to dividing complex numbers, okay? Yesterday we talked about this word, we already took notes on it, conjugates, okay? So here, why are these two conjugates of each other? What sign's different? Yeah, the adding and subtracting. It is adding or subtracting the opposite imaginary term. Okay, so are these two conjugates? Yes, how do I know? Right, one thing I want to talk about here, I'm going to make this a little bigger. We have negative 2 plus I, and its conjugate is negative 2 minus I. Why did this one not change signs? Why did that one stay the same? That's the A value, right? The only sign that's changing is the one in front, or the one that's with the imaginary term. Okay, so that constant is always going to stay the same. Capiche? Okay. And we already talked about when we multiply the conjugates, what happens when we multiply those together? What's going to come out of it? Let's find out. Let's multiply these together. You don't have to write it down, just follow along. How do I multiply these out? Negative 2 times negative 2 is? 4, thank you. What's negative 2 times negative I?
2i.
Positive 2i. What's I times negative 2?
Negative 2.
Negative 2i. And then I times negative I squared. Sorry. I times negative I. Negative I squared. Okay, what happened here? What do you see?
2i's are negative.
2i minus 2i, what happens? They cancel. Okay, what else do we have to watch out for? I squared. What does that turn into? Negative 1. Notice what's right here. It's another negative 1. Okay, so did anything happen to this 4? No. What's negative 1 times negative 1? 1. So lastly, what's 4 plus 1? 5. So what is going to happen every time you multiply conjugates together? You're going to get a whole number. Okay? Anytime you multiply conjugates together, you're going to end up with a whole number. Okay? And the reason for that is because these are going to end up canceling each other out in the middle. Okay? All right, off to the side of your example 4, I want you to write this example down. 8 divided by the square root of 2. What is wrong with that? Any of you that have me in geometry or geometry concepts, there's something wrong with that expression there. You can't divide that, right? Big red flag, you cannot have radicals in the bottom. Okay, you cannot have square roots in the bottom. Does anyone remember how we get rid of that? Yep, we're going to multiply by whatever that radical is in the bottom. So I'm going to multiply by the square root of 2 on the bottom, and I'm going to multiply that on the top. Why do I do the bottom and the top? Or why can't I do that? If I divide these out, what's the square root of 2 divided by the square root of 2? 1, right? Because these would essentially cancel each other out. So am I changing the value of what we originally started with by multiplying by 1? No. So that's the reason we can do this here. Okay. So how we multiply fractions is we're going to multiply straight across. What's 8 times the square root of 2? What do we do with a whole number and a radical when we multiply them? They just go together. 8 square root of 2. Multiplying here, what's the square root of 2 times the square root of 2? These ones we can multiply the numbers in the middle. So that's the square root of 4. Okay. Notice how we still have a radical in the bottom. But can we simplify that radical? Yeah. So the top's going to stay the same. 8 square root of 2. What is the square root of 4? 2. Okay. Now, I'm not going to be too picky about this right now, but can we simplify 8 divided by 2, which is 4? So our final answer for this one would be 4 square root of 2. What we got there is the same thing that we started with. It's just in a nice simple form, okay, because it does not have the radical on the bottom. Let's go ahead and turn this with complex numbers. Okay, or a plus bi. Go ahead and write off to the side. 2 divided by 7 minus 8i. Okay. Similar as having radicals in the bottom, we cannot have complex numbers in the bottom. How do I know there's a complex number in the bottom? I. Okay, because remember that I stands for square root of -1. We can't have that. Okay. What's going to get rid of that I? Multiplied by what? What's going to get rid of this conjugate and turn... Sorry, I just told you. What's going to get rid of that complex number to turn it into a whole number? The conjugate, okay? What is the conjugate of 7 minus 8i? Yep, 7 plus 8i. Go ahead and write this down. What I do to the bottom, I'm also going to do the top. Okay? So, we're going to simplify here. This is multiplication. So this 2, I'm going to take 2 times 7, which is 14. And then 2 times 8i, which is 16i, divided by, now we got to do some foiling on the bottom. What is 7 times 7? 49. What is 7 times 8i? Plus 56i. Yep. What is negative 8i times 7? Negative 56i. And then negative 8i times 8i. Negative 64 I squared. Okay, notice how we still have imaginary numbers, complex numbers in the bottom, but we can simplify this here. Can I do anything with the top right now? No, I'm going to keep that the same. Okay, what is going to happen when I simplify this bottom part here? Yeah, these cancel each other out because they end up getting 0. What else do we have to take care of? The squared. What is I squared equal to? -1. So we still have that 49. 49. What's negative 64 times -1? Positive 64. What's the last thing I can do here? Yep, so the top we're going to have 14 plus 6i. What do I get when I add those two together? 113. Here's how we know if we're done. Do I have a complex number in the bottom? No. No, that's how you know you're done. Okay, when I no longer have a complex number in the bottom or that I figure, okay, we're done. Okay, that is fully simplified there. So your example 4a has 80 divided by 2 minus 6i. Okay, what's wrong with this right now? There's an imaginary complex number on the bottom. How do I get rid of that? Conjugate. What is the conjugate of 2 minus 6i? 2 plus 6i. What you do to the bottom? Do the top. Okay, what does this turn into? What am I going to do straight across? Multiply, right? What's 80 times 2? 160 plus, what's 180 times 6? Or sorry, 80 times 6. I know we're getting a little big numbers here. It is 480. What's with that 480? I. Divided by, what do we do with that bottom, those bottom two? What did you say? Foil. Yep, distribute. 2 times 2. 4, 2 times 6i. 12i. What's negative 6i times 2? Negative 12i. And then what's negative 6i times 6i? Yes. Negative 36. What's with that? I squared. Okay, looking at this, can I do anything with the top? Any simplifying? No. Top is done for now. What happens on the bottom? 12 i's cancel. I squared becomes -1. So we still have 4, correct? What's negative 36 times -1? Positive 36. What's the last thing I can do here? Add the bottom two together. What is 4 plus 36? 40. For now, I am not going to be picky about simplifying, okay? I am more concerned about you getting to this step here, okay? Eventually, we will simplify. We take, factor these out, and we could factor these out to simplify that a little bit better, okay? But right now, I'm not too worried about that. I just want to get you to that bottom step, okay? Okay, go ahead and write this example off to the side. X squared plus 4 equal to 0. Okay, we're going to talk about how to solve these radical expressions. Okay, again, when we're solving an equation, what is the main goal? What are we trying to isolate? What are we trying to get by itself?
Get the x by itself.
Trying to get x by itself. So what would my first step be for this one? Yep, go ahead, subtract 4. So we have x squared equals what? Negative 4. Okay, what was my last step to get x by itself here? Yep, opposite of a square is to take the square root. Okay, what's the square root of x squared? X. What is the square root of negative 4?
2. No, wait, you can't make it.
Can't do that, right? What did we learn yesterday? What replaces that negative? I. So what's the square root of 4 originally? 2, and then that imaginary number I. Because remember, recap, I split this up yesterday like this. Okay, so the square root of 4 is 2. Square root of negative 1 is I. How many answers should you have when you take the square root of a number? 2. So we should have positive or negative 2i. That's your answer there. Part A says x squared plus 49 equals 0. Again, we have an equation, so our whole goal is to get x by itself. How do I do that? Subtract 49. So we get x squared equals negative 49. What's my last step to solve? Square root. So we get x equals 7i. How many answers should we have?
2.
Positive, negative. Yep.
Do you mind if we write it like that? Like the positive, negative, if you want to screw up the whole?
You can write it like that. Yep. You mean write like x equals 7i and x equals negative 7i? I'm cool with that positive, negative. Yep. Okay, let's talk about part B. 9x squared plus 25 equals 0. Yep, we got to subtract 25 first. We get 9x squared equals negative 25. What's our next step to get x by itself? What should we do? Divide by 9. Okay. Can I take negative 25 divided by 9 and get a whole number? No. So I'm going to tell you keep this as a fraction for now. Okay. What would our last step be to get x by itself? Square root. So we have x equals, does anyone remember how to take the square root of a fraction? I'm going to come over to this side. Okay, when you take the square root of a fraction, you can think I'm taking the square root of the top and the bottom separately. So what's the square root of negative 25? 5i. Okay, where's that I come from? The negative. Okay, and then what is the square root of 9? 3. How many answers should we have? 2, so we need that plus minus. All right, a little more review here. What's wrong with this expression right now? Yes, we cannot have this imaginary number, that complex number in the bottom, so we have to multiply by what? 3 plus I. Yep, you're changing the sign in front of that imaginary number. Okay, so on the top, We multiply, what is 4 times 3? 12. What's 4 times I? 4I. Now on the bottom, what's 3 times 3? 9. 3 times I? 3I. Yep, this one turns to negative 3I. This one turns into minus I squared. Did anything happen, or can we do anything with the top? No, that's going to stay 12 plus 4I. What happens on the bottom? These cancel, right? What about this guy? Turns into negative 1. So we still have 9. 9, what's negative times negative 1? Plus 1. Okay, again, did anything happen on the top? Nope. 12 plus 4I equals 10. I'm cool with you leaving it like that. Okay, number 7 has x squared plus 16 equals 0. How do I solve this? Subtract 16. So we have x squared equals negative 16. How do I solve from here? Square root. So we get x equals positive and negative 4I. Okay, last one. Stay focused, please. We have y squared equals negative 25. What do I do from here? Why can we directly take the square root right away? It's already by itself. Take the square root of both sides. What do we get for our answer? Positive negative 5I.